The integration rules for sine and cos are shown below. The integral for sine of nx plus b dx is equal to negative 1 over n cos of nx plus b, and then constant of integration on the outside. Cos of nx plus b, when you integrate it, becomes 1 over n sine of nx plus b, and then constant of integration on the outside. The main difference between the two is sine becomes negative cos, but cos becomes positive sine. So just note the two differences between the two. Now, for this example, we're asked to evaluate the integral from 0 to pi on 2 of cos of x minus pi on 6 dx. So unlike the previous examples with the rules, we're asked to find the definite integral, which is the integral, but after substituting in certain bounds. So the first thing we have to do is find the rule of integration and then substitute in those bounds at the end. So this, if we simplify it, is going to become, or the integral of cos is sine, n is equal to 1, b is equal to negative pi on 6. So this simply becomes sine of x minus pi on 6. Now, as per the previous video, the bounds go at the top and the bottom respectively, and then we substitute those in. So the first thing is going to be sine of pi on 2 minus pi on 6, and then we minus sine of 0 minus pi on 6. Now sine of pi on 2 minus pi on 6, pi on 2 minus pi on 6 is pi on 3. We could do that on paper by making the denominators the same. So it'll be sine of pi on 3 minus sine of 0 minus pi on 6. That simply becomes negative pi on 6. Sine of pi on 3, we should memorize our sine, cos, and tan exact values in between 0 and pi on 2. Sine of pi on 3 is square root of 3 over 2. Sine of negative pi on 6, you could take the negative out of a sine and it becomes negative. But then negative cancels out with this minus, so it becomes plus sine of pi on 6. And we should know that sine of pi on 6 is equal to 1/2. So the exact value of our definite integral is square root 3 over 2 plus 1/2. Now, in the previous video, we used integrals to calculate an area. In this case, we use definite integrals to just evaluate a definite integral. The question never asked us to calculate any area. So for this type of question, don't write units squared. It's not appropriate to the question. Only use units squared if it asks you to specifically calculate an area and you use definite integral to calculate that area. Okay. So in this next question, it specifically asks us to calculate an area. So in this case, we need a unit squared at the end of our answer. So let's apply the sine rule, the sine integration rule, to find the area bound by y is equal to sine of x, the x-axis, x is equal to 0, and x is equal to 5 pi on 4. So x equals 0 starts here. One cycle of sine of 2x is pi, because a period of sine is 2 pi over n. So in this case, it's 2 pi over 2, which is pi. 5 pi on 4 is a bit bigger than pi, so 5 pi on 4 is roughly here. Sweet. So we're trying to find the area from here to here, bound by y is equal to sine of 2x and the x-axis. So that is simply this, this, and this, all added together. Now what we could do is the integral from here to here, minus the integral from here to here, because it's below the axes, plus the integral from here to here. Now, this would get you the answer technically, but there's a bit of a shortcut with sine, cos, and tans. Due to the symmetry, this area is equal to this area here. So this is equal to this. 1 is equal to 2. So we could just evaluate one of them and multiply that integral by 2, and that would be calculating the area underneath both of those sections. Then we just have to add this little section here. So let's do that now. The area is going to equal 2 multiplied by the integral. You could choose either one. I'm just going to choose the one above the axes because it's easier to evaluate. 2 times the integral from 0 to pi on 2 of our rule, which is sine 2x dx. And then we add our little section to the right there. It's going to be from pi on 2 to 5 pi on 4. So it shouldn't be pi on 2, it should be pi. It should be from pi to 5 pi on 4, from this to here. Same rule, obviously. Now let's evaluate each of these now. So we've got 2 multiplied by the integral of sine of 2x. That becomes negative 1/2 cos of 2x from 0 to pi on 2. Now, before I evaluate any of this, what I'm going to do is try and simplify it, because there are some things that we can simplify before we actually start evaluating. It's going to make our life much easier when we need to combine everything later. Now, the first thing I can see is the 2 cancels out with 1/2. So I can just erase them completely. I'm just left with negative cos of 2x from 0 to pi on 2. The next thing that I can simplify is the negative. I can take out the negative and I can swap around my bounds. So 0 will go to the top, pi on 2 will go to the bottom. Now that makes everything a lot easier to calculate. Now the other integral becomes the same rule, negative 1/2 cos of 2x from pi to 5 pi on 4. Now there's no 2 to calculate on the outside, or to simplify with on the outside, but we can still swap our bounds. So pi will go to the top, and 5 pi on 4 will go to the bottom. And now this is much easier to simplify. So let's substitute in the bounds of the first integral. We have cos of 0 minus cos of 2 times pi on 2. And then we plus 1/2 cos of 2 pi. Then we minus 1/2 cos of 2 multiplied by 5 pi over 4. This is just substituting in all the bounds. Now let's just simplify everything. Cos of 0 we should know becomes 1. Cos of 2 times pi on 2, that's cos of pi, that we should know that becomes negative 1. Then we add 1/2 cos of 2 pi. Cos of 2 pi is the same as cos of 0, which is 1, but obviously multiplied by 1/2, it's just 1/2. Minus 1/2 cos of 2 times 5 pi on 4. 2 times 5 pi on 4 becomes 5 pi on 2. Now 5 pi on 2, what I do to evaluate this one, or to simplify this one, is I draw out the unit circle and I draw out where 5 pi on 2 is. And that'll give me an indication about what the cos value will be, because we should know that on the circle, cos is just the x value. Now 4 pi on 2 is the same as 2 pi, so this is 4 pi on 2. If we add an extra pi on 2, that just goes to that branch there. So 5 pi on 2 lies there. The cos of 5 pi on 2, or the x value, is just 0. So that just becomes 0 there. So that's actually really easy to evaluate, because it's on that axis, and we should know on the y-axis the cos value is 0 because the x value is 0. Sweet. Now let's combine all of our terms. We've got 1 plus 1 plus 1/2 minus 0. So we're getting 1 plus 1, which is 2, plus 1/2, which is 5 over 2. Now this is our exact area, which we'll write with units squared because we did evaluate the area just then.